The sum rule allows us to break it up, just like we did with limits when we had a limit of two different functions. Actually, I think the way we wrote it was just f plus g. We were able to split that up and take the limit of f plus the limit of g, which really told us that we could just take it term by term. And that's true with the sum rule as well. So in the sum rule, we can split this up and say the derivative of f of the quantity of f plus g is equal to the sum of the derivatives. This also works for multiple functions, so I can have as many terms as I want, and I can still, as long as they're separated by terms with a plus sign, or I also have a difference rule or a minus sign, and I just follow through with whatever sign was between the functions, I keep between the terms. So let's start with taking the derivative of this polynomial. See, it's got a lot of terms and they're pretty big. It'd be pretty messed up into a limit. But now that we have this sum and difference rule, I can rewrite that and just take it term by term. And just take the first term would be the derivative of that first term. And then use the plus sign. And then the derivative of the second term. And using the minus sign this time to get to the third term. So just be consistent with the signs, and then you can take it term by term. Oops, it's a pretty long one. So I'm actually going to erase my highlights here. And let's just take it term by term. So the derivative of x to the 8th is 8x. The derivative of x to the 5th, remember we're going to use our constant rule and our power rule here, so I can take 5 times 12 to get 60, and then I have x to the 4th. And then I have, again, a constant rule combined with my power rule. So I take the 4 down and multiply it by the constant in front. So I get 16 times x cubed. Be consistent with your signs. That was a minus, so this one's a plus. And I have 10x cubed, so I'm going to bring that 3 down, multiply it by the constant. And then 6x, that is just 6. And then a constant is 0. And that one we don't really even need to write. So that leaves us with this. And once you know this rule, you don't necessarily need to write this step. You can just know that when I take the derivative of this, I can take it term by term. And just keep consistent with whatever sign goes between those terms.